So question I, we want this x to be on its own. We want to find a solution and find out what the value of x is. So to do that, we have to get rid of this divide 2. How do you get rid of divide 2? We have to times by 2 on the left hand side, and if we times by 2 on the left hand side, we have to times by 2 on the right hand side. So on the left hand side, this divide 2 and this times 2 cancels out, leaving us with just x, and on the right hand side we will have 5 times 2, which is 10, and because we haven't multiplied or divided by a negative number, the sign just stays the same. So on the number line, because I can see 10, I'm going to put a circle just above 10, and then it's less than 10, so the arrow will go this way, but I can also see there's an equal sign there, so therefore I will have to shade this in. If it was just x like this, then I wouldn't shade it in, it would just be an open circle like that and then like this, but that was not the question. This is just an additional explanation. So if they asked you for the largest value of x, the largest possible value of x, then the answer would be 10, because x can be 10, because equal to, as you can see in the sign here. So question J now. So we want this x on its own, so we have to get rid of the divide 4. How do you get rid of divide 4? Well, we have to times 4 on this side, so that means we have to times 4 on the other side as well. So on the left hand side, the divide 4 and the times 4 cancel out, leaving just x, and on the right hand side 3 times 4 is 12, and because we haven't multiplied or divided by any negative numbers, we can just copy the sign as it is. So x has to be greater than 12. So on our number line, 12 is here, and because it said x has to be greater than 12, the arrow will go this way. So if they asked us what's the smallest possible integer for this inequality, then the answer would be x is equal to 13, because x can't be equal to 12. It has to be greater than 12. Question K now. We want to get rid of this x here. So to do that, we have to first of all get rid of this divide 4. So to get rid of this divide 4, we're going to times 4 on this side, and we're going to times 4 on this side. So because we've times it by 4, this divide 4 and this times 4 cancels out on the left, leaving us with just 3x, and on the right hand side 9 times 4, so we're doing this, so 9 times 4 is 32, sorry 36, not 32, 9 times 4 is 36, and we just copy the sign as it is. And now to get this x on its own, we have to divide the left hand side by 3, and if we divide the left hand side by 3, we should divide the right hand side by 3 as well. So now on the left hand side, the times 3 and the divide 2 cancels out, leaving us just x, and 36 divided by 3 is just 12. I'll just copy the sign down as it is. So to show this on a number line now, so because I can see 12, I'm going to circle the 12, and because x has to be greater than 12, I'm going to put the arrow like that, and because I can see the equal sign as well, I'm going to have to shade the circle in. So x has to be equal to or greater than 12. So if they asked us what's the smallest possible value or what's the smallest possible integer value for x, we have to write x is equal to 12, because x can equal 12. X is 12 or more. Question L now. So we want to get this x by itself. So to do that, we have to first of all get rid of this divide 5 first. We have to get rid of the divide 5 first. So we go to divide 5 by times in both sides by 5. So now on the left hand side, the divide 5 and the times 5 cancels out, leaving just 2x. And on the right hand side, this bit here, well, the 10 times 5 is 50, and just copy the sign down. Okay, and now we want to get the xy on its own again, so we have to get rid of the times 2. So to get rid of the times 2, we have to divide both sides by 2. So on the left hand side, the times 2 and the divide 2 cancels out, leaving us just x. And on the right hand side, this bit here, 50 divided by 2 is just 25. I'll just copy the sign down because we have not multiplied or divided by a negative number. So where would 25 be? 25 would be somewhere in between 20 and 30 here. We'll just draw an arrow going this way. Can be any length you want really. So this shows that x has to be less than 25. So if they asked us what was the largest possible integer value for x, if they asked us what's the largest possible value for what's the largest integer that could be x, the answer would be 24. X is equal to 24 because x cannot be 25. I would now like to try question 11 by itself. So question 11, A and B are there. Then you've got question C, which has got quite a few questions. 9 questions on it. Okay, so question 11. I'll pause it for a little bit here. So you can pause it and try and do question A and B first. After you've done A and B, you can try question C. So question C 1 to 8 is there. And then this is question 9. Question 9 is more of a word or a scenario based question. So I'd like to try those questions by yourself, and then I will explain it in the next clip. So question 11, I would like to try by yourself. So question 11a, write down two possible values of x. So this is x for the inequality x is less than minus 2. Then here, write down the integer values of x. And then there's two questions here for you. And all of these here, they're x's, not times. They're all x's.